All right, gang, we're here picking up where we left off on our Discord. We're picking up where we last left off on our little build through our walkthrough, this full stack fundamentals walkthrough, where I scaffolded out, I think I typically call it, some REST API routes that just send generic messages. It just lets me know that my routers are all synced up correctly. I have these methods and endpoints doing what they should be doing. I have the expectations of my get one, my put, and my delete taking the router parameter and understanding that it starts off as a string until I turn it into a number. I may not necessarily always have to do that, but since we're going to be using numbered IDs, I probably go ahead and should do that. We've talked about adding up our posts and making sure our rec body can be sent back to us as an echo in our responses to make sure everything is just wired up correctly. But I know this series was originally spawned from people having difficulty understanding how the server, my phone goes off, Discord's going off the second I click recording. It was totally quiet, not but like 20 to 30 minutes ago. Everyone's difficulty comes in how does the data flow from one place to the other, and that's actually what we're going to be getting at a surface level here. Whenever I'm done working in a particular side of my project, I like to close and collapse those files and folders to make sure I have a clear head and a clear mind. So a lot of the times in your server folder, you will have something akin to this, a DB folder or something like it, something like models or records or services, and you're going to have something that connects to your chosen database, whether that is connecting and creating a new record with MongoDB or connecting to an existing MySQL server that, if you've been following along in our course, you have a MySQL server, whether it's 5.7 or 8, it doesn't really matter to me. I can help y'all debug anything. And probably using the MySQL workbench of those two versions as well to talk to said SQL server, right? So we have MySQL server running and MySQL workbench as our graphical user interface or GUI to interact with it. We're somehow going to have to connect to that MySQL server the same way our workbench connects to it. So essentially, this little, I mean, yours might be called localhost or local dev or something like that. You probably don't have all these goofy ones here, but this connection right here is what you're going to have to recreate in this file, essentially. Sort of, but not really. But you know what? We actually haven't talked about what this project is going to do. I mentioned that we're going to not make it insanely feature-rich, as that's going to come later and on your own time, really. We're here to talk about the fundamentals and not make the craziest to-do list app ever, even though I think it'd be a lot of fun to do so. Maybe we'll add that after Full Stack Fundamentals, I feel like, has reached its logical conclusion. If there is one, really. I guess it really wouldn't be. We'll dive into maybe doing something more advanced from there. We'll go full stack features and we'll start just coding random features for better or worse on our application. So I'm going to have to take a pause from Visual Studio and jump to my workbench because I haven't even created the schema yet. So we need to do that. So here is typically what I do before I even start coding is I think of what does my project need to know and how do I combine that information, right? Because in SQL, you want to keep tables isolated, and you join their information together via what are called foreign keys. So you probably don't have this many dumb schemas as I do, and I can't really zoom in on them. I can make this font bigger, but I can't really zoom in on this. But we need to make a new one. So how about I call it by the same name of my project, which I totally remembered, don't judge me. To-dos full stack, that's a dumb name. We'll call it to-dos app. So I'll say, hey MySQL, create a schema called Todos app, to-dos app like that. And you can hit on Mac Command Enter or on Windows Control Enter for a shortcut instead of having to highlight and click on the lightning bolt icon or the lightning bolt text cursor icon. As long as you're competent about placing your semicolons at the end of the appropriate line, clicking at the end of that line with your text cursor, and when it's blinking there, hitting Control Enter will allow you to run a command shorthand style. So now that I have my schema created, I can refresh this list and see it here down yonder. Sorry, again, I can't zoom in on it. And it's not in use yet, so the queries I write will be running on something I have called catstagram that I've been doing earlier. So we have to also make sure to use said schema. There we go. Now the schema's in use, and the next queries I write will exist on that schema and not another one. So a very good starting point, no matter what it's called. It could be users, authors, players. It's a table that's going to correspond to if someone fills out a registration or login form or hits a profile page, that information will probably be spawned from here. And this is pretty much a good starting point for a lot of y'all's projects, especially after this course. You want to build some CRUD project of some kind, this is the place to be. So we need some way to identify these users, and while I normally don't use integers in my development, I like to use something called UUID strings that are generated from my Express server when people are created and registered and those post routes are hit. We'll keep things simple and just use the IDs here. We're going to make sure that they're going to auto increment like that. There we go, and they should be automatically filled in. Now, I run my create tables syntax-wise a little bit differently than what's in the course and Matt Landers' videos, but you'll see that the way I do it, I think kind of makes more logical sense, and it's easier to understand when you see the breakdown of how I do it. So the first thing I do is I describe all my tables, my columns in the table, and if they are, and what their data types are, if they're required or not, they have default values, their size, etc. And then I talk about keys at the bottom of my create table. So let's just keep going. So what do we want to know about our users? Well, they're not going to have to register, and I want the email address. We're going to use that as a varchar. 60 characters, 100 characters. Let's say 100 characters. This is a good default value. That's going to be required, so we're going to mark it as not null. And we want to make sure that people can't register multiple emails over and over and over again, and that unique keyword will prevent people from doing that. It is also case insensitive, meaning I can't register capital L Luke at Covalence.io and lowercase l Luke at Covalence.io as two different emails. Instead, they're going to be the same email address and this unique keyword. So that's actually going to give us some database level, at the lowest possible level, security from people registering spam email addresses against us simply by changing one letter's casing over and over and over again. Probably the same thing if you want a username. I mean, I don't know if we have to have a username, but we can do like first name, varchar 60. And if you're wondering, hey, Luke, how do I know what size of varchar or varchar? You can call it whatever you want, really. Whatever varchar size you want, how do you know what to do? Honestly, I just kind of take guesses until I feel like it doesn't work. I'm sure there's some kind of set, there's not really a standard or rule, but I'm sure there's a set thing going, oh, you should probably just do 50 for someone's first name. No one's going to have a first name that's this many characters, and we can argue we can probably get away with something even less than that depending on what we know our core client base is going to be. So someone can't register a first name of like 50 or 100 question marks and look and ruin your application and things like that. So essentially you'd have an entire role, a database administrator, a DBA, whose purpose would be to come in here and literally chop it down memory byte by memory byte by memory byte until it gets to the absolute bare minimum. Because these SQL databases are meant to house millions of rows of information. So the smaller memory size you can allocate per column, the faster your queries are going to be when you're having to say, hey, find this one email address among 32 million of them. So the faster you can make that, the better off you're going to be. So you'd have someone here just simply chipping away and honing down on these column sizes until they're absolutely at their tightest. So we can get away with some sloppy column sizes and just hone them in later down the line. We'll do a last name column for when registered, like that. Those can be a bit longer, so maybe I'll go with 50 on that one. What else do we want to have? Well, we're gonna talk about this later, so let's do a varchar 60 for their password. No, we'll make it plain text for now, and we'll talk about what a hash looks like later. But we can actually just go find a hash online and paste it in there as if it was a pretend fake password, because in the database, you never want to store plain text passwords, like password 123. That's what we're going to log in with, but in the database, we're going to store a encrypted version instead. We also probably want to know when the user had registered. So we'll call that the created at column. Now, you might see it as underscore created. I like to label them as created underscore at. We can just label the column pizza for all that it really matters. Just use something intuitive that makes sense. Create users created at, that's when we made the row or when they registered. Now here, instead of using date time, I'll be using a timestamp column. And we can do current underscore timestamp. Now parentheses is a SQL function that can also grab the same current timestamp. It's a different way of writing the same thing. I like to expose you all to new things like that. And timestamp is still the same format as a date time column. I believe the date time column has an acceptable year range from the year 1000 all the way to the year 9999 with all months and days in between that. That's a pretty big range, and I highly doubt someone's going to be registering their account, well, before today or past the year 9999. I highly doubt, and I would be very impressed if your application lasted that many years. Granted, it'll all be dead, so you couldn't prove me wrong. However, good to know. So why did I choose a timestamp column rather than a date time, considering date time is fine? Well, we had just got done talking about honing in your column sizes as best as you can. So I believe a timestamp, I mean, I should probably look it up, but I think it was something like that. You know what, rather than make a fool of myself, let's just Google it up real quick. So essentially you can see there, based on my guesses, that the timestamp column accepts a smaller range of time compared to date time. Yeah, okay. No, God, I'm so good. Okay, so 1970 to 2038 is the maximum acceptable range for a timestamp column. This is perfect for auto-generated created ats, but maybe not so good for birthdays. I highly doubt you're going to have any boomers before 1970 coming in here to learn this code stuff. Comments prove me wrong, that are born before that time, but you can see that a timestamp column is probably not a good idea for something like a date of birth column. But for auto-generated timestamps that simply represent when did somebody update their profile or when did somebody register their profile, perfect, because it's going to be happening in this range and take up less memory than a date time column, which means we've already made this slightly more efficient than some of our chirper labs, for example. Okay, now that I think this is a pretty good baseline for starting out my users table, I now need to provide the one crucial bit of information that every table must have: a primary key. What and how, like which one of these columns could MySQL uniquely identify each row by that would never be repeated again? It must be a unique, non-repeating key that's easy to find. So we actually have more than one candidate. You might be thinking, well, as long as I don't register users at the exact same time, technically the created at column could be a good unique key, right? Because no one should have the exact same nanosecond or millisecond registration time. But when you have millions of concurrent users, the chances of two people possibly registering at the exact same time, while infinitely low, are still not impossible, just highly improbable. So while it could work, probably not a good idea. We could use the email column, as that is a unique column that cannot be repeated ever because of that unique keyword we're putting on it. And that could work. It's a unique value. It won't be repeated. It can be an easy way to identify rows, no problem. Even better would be our auto-incrementing ID, 1, 2, 3, 4, 5, 6, etc., until it overflows for ints, whatever that size was. That'll just continually keep incrementing a number until we run out of space. And so that's always going to be an easy and fast, unique way of primary keying our table. So I'm going to go ahead and tell it, use the primary key ID. So we can also include the primary keyword up here. You see that a lot in our course. But I like to keep the top half of my table, or top third, top 2/3, the description of what each user is going to have, of what each row in that table represents, and then I put my key information down here. We don't actually save ourselves a lot of time and space here in the users table, but when we start building out the other tables, you'll see the advantages of that setup. I'm going to go ahead and run that create table. We get full green check marks, and we're good to go. Moving on down. Well, this app is about building a to-do list, so I might as well build a table of to-do items. Each of these items is going to have some of the same columns, the exact same ID int auto increment, the same created at timestamp column, so I can just track which ones were made and when. I might also add a completed at, so I know when they were completed. This may not actually, on the back end, this really won't matter when I completed it, but on a website, maybe a user wants to filter when they completed their particular task. So maybe we'll have that be a default timestamp, and we're just going to leave it as a nullable value because we're going to fill that in when the time comes, when they mark, I have completed this, or something like that. We're also going to want to know who this thing belongs to. So I'm going to make a column called user ID that's going to be an integer that's going to be required. This task, or this to-do list item, has to belong to somebody. And that's going to correspond to whatever their ID is over here. That is the relationship. So if I register myself as user 1 and I write 5 to-do items, they're all going to belong to user 1. If my cat Percival registers and becomes user ID 2 and he has one task, which is eat dinner, yeah, after 4 o'clock, he'll want dinner around like 7 or 8. He has that one task on mine today, eat dinner. That means his user ID will be ID 2 for that particular task because it belongs to him and not me. And that's how we can have that cool feature on the front end to say, filter the to-do items by somebody's user ID. Filter all of Percy's. Filter all of mine. That's a cool feature you can do with that. And that way you can also make sure that anybody that adds a to-do item must exist in your database. And we'll talk about how that works here in a minute. And then we need the content of the task itself. Considering this is the to-do list app, I think 255 should be enough characters to write whatever task I want. I can always increase that later if I think I'm going to be leaving myself big descriptions or paragraphs, or maybe I can have content act as the title and then like an optional description varchar that might be like 500 or 600 or 1,000 characters, something bigger than that, for example. Okay, well, that's pretty cool. What else might we want to know? Well, we want to know if it's completed or not, and here's where it can have some fun. Well, there isn't really a Boolean type, to my knowledge. I should probably Google that before I say it with certainty. To my current knowledge base, before I've Googled something, there's not really a true or false Boolean type in SQL, but we can get around that by cheesing it with, say, even numbers. We can do something like a tiny integer, which, as you can imagine, is still a whole numbered integer, that it just takes up less possible space than an int, because we're not going to be using anything other than, you guessed it, 0 or 1. We can say anything that's not completed is a 0 value. Anything that is completed is a 1 value. So whenever someone toggles something on our website, it would come here, find the row, and change the 0 to a 1. You could also take advantage of the following syntax as well. There you go. Or n, like that. We can say, rather than varchar, we can say this is a char. It'll always be the following 1 character in length, because varchar means it can be anywhere from none or up to 255 characters, whereas this means it always must be 1 letter in length, no matter what. N for not completed, and Y for, yeah, it has been completed. You can pick the number or the string value. It doesn't matter too much to me. I might leave it as the char1 string value and have it default to not completed whenever they make a new to-do list item. Very cool. Okay then, so we have which one this is, who wrote it, what the task is, what the to-do item is, whether it's completed or not, starting at when it was made, and when we complete it, we're going to fill that in when they also change this value. So it looks like these two will be updated with a put request later down the line from our application workflow. Very cool. I sound too professional in this one. I got to get loosey-goosey. I took a walk in between a couple of the videos, and I was listening to what I did, and I listened to a podcast called Syntax that, I don't know, like, my style isn't highly technical, so I feel like I'm being too rigid right now, so I don't know how to make this a little animatronic, so, alright, moving on. Forget about it. I might actually move, the column order really doesn't matter. I'm just being a neurotic weirdo by just moving completed at right below completed. I'm just being weird, so bear with me. We need a primary key of this table. Easy enough. It'll be the ID, and here's the magic sauce. Rather than having to write alter table add constraint, I can actually just write the foreign key in line during the table creation. I can say foreign key, which column, the user ID column, references, and which table, users table, which column inside of that, the ID column. I don't have to write add constraint and give it a constraint name of fk underscore whatever. MySQL will auto-generate those names for you. In projects of this size, that's totally fine. At the end of the day, the constraint name, when you write add constraint fk underscore stuff, whatever stuff you write, that's just like a variable name that identifies this particular foreign key, and it has to be unique in this particular schema. That's it. So I can actually depend on MySQL to generate them for me. So if I was in a big team or a larger project, I may consider writing the names myself to make sure I can document them and tell them to my team if they need to know them. But if I'm just writing this for myself and I have no intention of messing too much more with the foreign key other than with joining information, I'm just going to let MySQL generate it for me. And unless I have a syntax error, that should be enough to create my to-dos table. Okay. So this is the one feature that I want to do that's going to be a little overkill, but will be good practice. This is just like your blogs lab, where I'm going to create a table of tags because I want to be able to tag certain to-do items that have certain tags. So if I have stuff like long-term, short-term, productivity, diet, exercise, I want to be able to maybe add the ability to filter and find to-do lists that have certain tags. And that opens the door for a whole bunch of other features. I want to find everyone that has a to-do item that has a tag of exercise. Maybe I can find someone on this website that's also trying to get swole or lose some weight or do a diet, and maybe we can filter that out by the tags, find people that are doing a to-do list similar to us, and boom, you almost have like a little meetup style application that you built out of, well, just this one little feature that you added just to learn something here. So let's go with that. Same thing, I want to know which tag belongs where. And do we really care when these tags were created? No, not really. You know, we can make them whenever we want. So, I mean, maybe I want to organize them by the first tag versus the last tag. Maybe I just want to have this in here for some metadata. It's not that important, but I'm going to go ahead and copy and paste my created at column. And you can see these are two like just good columns to have, including a little primary key down here. And I can tell you this thing won't have any foreign keys, and so that's pretty good so far. And we could have the name of the tag be a varchar 60. It's got to be required. And we're going to make sure that someone can't enter exercise capital E and exercise lowercase e and have two different tags. So we're going to make sure that they're also unique so people can have can all have the same exercise tag, and I can always, on my code base from like the Express server or the React website via state, simply do a .to lowercase to make sure that's never an issue, but I'm also going to set up my database to prevent any accidental case problems. Always good. So that's it. It's going to, which tag ID is it? What is its name? And when was it made? Just for some metadata. Like I said, it may not actually help us on the front end at all, but you have it in the database and you can find out what's the first tag I ever made in this awesome application that we built on this awesome web series. And that's it. Let's fire that sucker up. Green check mark, good to go. Now here is the magic. We've talked about being able to apply multiple tags to the same to-do list item, and one to-do list item can have one or more tags, and those tags can belong to one or more to-do items, which means we have the classic example of a many-to-many relationship. That many-to-many relationship means we can't do what we did here. We cannot add simply the following tag ID int not null, and then come down here and copy the foreign key and change it to simply be tag ID tags ID. You could do that, but what's the problem now? The problem now is that we can only apply one tag per one to-do item. Oh, well, Luke, then just add tag ID 2 int not null. And then as you can see, the problem, it begins to scale out of control. We would have to keep on adding column names in order to keep accommodating more and more and more tags. And then we'd have one to-do item that has one tag when we have 20 tag columns all filled with null values, and it would never work. So you could also simply store and, use JavaScript to stringify or JSON stringify an array of numbers and then cast it back into an array when you get back into your code. I thought I had my phone on mute. Hopefully it's not an important call. I should probably pause and look at it. You know what? Forget the pause. Let's do it live. Well, live isn't a recording. Not spam. Go figure. Anyway. You could do some trickery where I had a student just make a varchar like 10,000 and he pretty much just JSON stringified like his entire React state, crammed it into the MySQL database and called it a day, and then just parse it when it came back out. I mean, that ain't exactly going to scale that hot, and you're completely going against the spirit of a structured query language like SQL, but it worked. And at the end of the day, that's all that really matters. So how about we explore the conventional solution instead for a many-to-many relationship? This table is going to allow us to do that. Create table, and we'll call it to-do tags, or to-dos tags, plural, because it could be multiple to-dos and multiple tags. Now, it's not going to have one solitary ID column like we've been doing so far. Instead, I'm going to have a to-do ID column, int not null, got to have a value, and a tag ID column, int not null, because it's got to have a tag value. And that's it. which to-do item has which tag. And with a join, we can find out what tag names with that join statement belong to this particular to-do item. The two of these together are going to act as our primary key, like the following. Primary key, to-do ID, tag ID. And that right there is called a primary composite key. The combination row of the to-do ID and the tag ID together make up the unique value. How does that help us? Good question, whoever just asked that. Let's imagine we have the following information in this thing. All right, we have to-do item 1, maybe that's my make this webinar, belonging to 1, code. My cat Percival has a to-do item that says watch or sleep on Luke's desk, and that also has to do with tag 1, which we can pretend is code. Then item 2 could also have the tag 2, which is sleep. So Percival's one task of sleeping on my desk has the tag for coding and the tag for sleeping as an example. You can see here that the number 2 can appear multiple times on the left-hand side, as well as the number 1 it could. And the number 1 on the right-hand side could also appear multiple times. So we can't just say, oh, 1 or this left-hand side is going to be the unique value. Or we can't do that because 2 appears on the left-hand side twice. So that's not unique because it appears once here, then once there. But if we look at them as a set, if each one of these, no, that didn't work. I was hoping it would just auto-highlight the pair like it does in VS Code. But if we look at all of these as a pair, each pair is unique. 1, 1, that makes sense. That's unique so far. So is this, and so is this. This also prevents us from writing the same by mistake. We would get an error because it would say, hey, you already have 1, 1 as a relationship in this table, so you can't insert it again. That way it prevents us from adding the same tag to the same to-do item by accident more than once. So I can't apply the coding tag 50 times to my one task because I think I'm funny by disrupting the database. This primary key relationship will prevent that from happening, which is super cool. Now, in case you want to join that information, you could also, this part isn't necessarily required, but it's nice to have, you can go ahead and foreign key both columns to their appropriate table. That way you can do a gigantic join statement to bring all that information in here. To-dos ID, foreign key. I'm surprised I can remember how to spell that thing finally. I would always misspell foreign key my first go around. I'll just double guess it every single time. I before E, except after 20 different exceptions. Thanks, English. There we go. And that's what a good to-dos table looks, or the many-to-many relationship table looks like. That'll be like the blog tags in the coming labs, or the mentions in the Chirper lab. Awesome. Something else we can talk about here. If you've done some SQLing so far, you know that, let's put it this way. Let's say my cat Percy has 10 to-do items. He has 10 tasks in my database, and he wants to delete his account. So he's going to come up here and delete his user account because he's tired of putting up with my garbage every single day. He's like, I'm tired of your productivity app. I'm a cat. I just want to chill and not have to log what I'm doing as to-do list. I'm like, fine, delete your account. And let's say he is ID 2. And he has 10 to-dos belonging to ID 2, to user ID 2. Here's the problem and what foreign keys present to us. I cannot simply come and delete ID 2 Percy because that means I now have 10 to-do items belonging to nobody. It won't let us do that because it goes, that doesn't make sense. You can't delete user ID 2 if user ID 2 isn't being referenced in 10 different to-do items. You can't do that because that means this number 2 points at nothing and I'm structured query language. I'm not going to let that happen. And it won't. So what we're going to have to do to delete Percy's account is to come first, delete his 10 to-do items, then delete his own row. So that's a two-step process when it comes to deleting a user account from our database. We must first delete their referenced ID everywhere else, and then we can come delete the user themselves. That's a two-step process. There is a way to automate that, and I typically don't recommend doing it, right? But down here, we would have to remember, let's say, and Percy was deleting 10 to-do items with 20 tags. So let's say his 10 to-do items had 20 tags associated, so about 2 per to-do task that he had listed. We once again could not delete. We could not delete Percy's 10 to-do items from this table before we first go annihilate the references in this many-to-many to-dos tags table. We couldn't do that because that means we'd have 20 tags that belong to question marks, to nothing. And that foreign key won't let that happen. So the foreign key acts as this like kind of secure or sanitized step going, are you sure you want to delete that to-do list? Because you're kind of talking about it and describing it down here as well. So that guy ain't gonna know what they're talking about if you delete it from this over here. So like I said, we can automate that, and then I don't typically recommend this, especially for big things like to-do items or users and things like that. But this little tags table, like if we don't want to have to remember that we're going to be deleting this thing, there's actually a little keyword we can throw on these guys here. I can put on delete cascade on both of these foreign keys, like that. This will automatically, if I delete a to-do item, it will automatically come down here and scrub this table of the very same to-do keys. Cool, we could do that. This one here, it makes sense to have that automation because maybe I don't care about this relationship if they happen to delete their to-do task. We just annihilate it. And that way it'll automate that delete process so I won't have to remember delete from to-do tags first, then delete to-do item. So again, I normally don't recommend this, but I think it's important to know how to do it. Because if you put on delete cascade everywhere and everything's automated and you accidentally delete one user, you could inadvertently delete hundreds of other things from other tables that probably shouldn't have gotten deleted just because you automated it all, which is why everything in development is a trade-off. If I make this decision now, I'm going to have to pay for it somehow down the line, whether by remembering to always run multiple delete statements when deleting things, or if I know something's automated, being very, very careful when testing my delete functionality. So keep that in mind. Everything's a payoff. That right there should round it out for our to-dos tags table. So this demo for this schema has gone on a little bit longer than I intended to, but I think there's some good core stuff to know here. And I think this is a pretty good starting off point for what my application is going to do. Again, we're going to keep it simple feature-wise, but let's talk about them fundamentals. So with all this stuff created, what I like to do for a lot of my projects, especially if I'm going to be sharing it with students or an instructor to help me, or a team, or if I want an employer to take a look at how my schema looks like so they can see my competency on the back end if it's something cool I really did, I would like to go to my particular repository. I'm going to make a new file. We'll maybe call it the schema.sql or something like that, schema.sql. I can paste all of my fun SQL syntax here, and now I have kind of like a pseudo documentation of what this project is going to use. So if someone wants to help me on this and they want to recreate it on their own computer, they don't have to guess what our schema looks like. They can just come to here and check it out. The only caveat with this is, remember when I talked about trade-offs, it just means that every time I run something or change something in my workbench, I'm going to have to remember to come and update it over here if I alter one of my tables. Otherwise, this will fall out of sync and someone trying to help us or review our code couldn't do so that well. Now, obviously, in like a big team with separate like database teams and server teams and client teams, there's going to be so much like compartmentalization or like division of labor that you're not going to have to do this. But if you're writing solo projects or small group projects that you're working on with friends or other developer friends, this is a good idea to have a shared file that y'all can look at for the shared schema, unless you'll have some kind of shared database on the cloud somewhere, which is another solution. Again, there's always different solutions to different problems, but this is pretty good for you, the newbie student, to get in there and make sure that someone can look at your code quickly and be able to devise how they can help you. Hey, I've got a problem with my query. Well, I can't probably help you if it's a join statement because I don't know what you're trying to join, the names of your tables, the names of your columns. I'd have to just slowly chip away and guess it over time. But if I took a look at this and you had a problem with a query that had a join statement, I can look at your tables here and tell you probably exactly what's wrong with it without even looking at your query. So that'll round it out for this video where we talked about this schema. The next one, we're actually going to dive into finally connecting this stuff back to our database somehow. See y'all then. But not to our database, to our server somehow. From our database to our server. I can't talk. Bye.